All right, now we're going to do some practice quizzes. And I'm going to go ahead and do them all, even though there's going to be, excuse me, some redundancy. So certainly you don't have to watch them all. You can skip ahead. But I'm going to do all of the practice quizzes in this one PDF that you've got. So I'm going to start with the first one. It says Practice Quiz 6.1, and it gives me a couple of points. Well, it gives me a lot of stuff, but I'm going to start with these 2 points, A and B, that are given, and I'm going to find the coordinates of vector AB. So the vector that starts at A and stops at B. So that would be positive 5 and positive 4. So from 1 to 6, that's 5 steps forward. From negative 2 to 2, that's 4 steps forward. Or you can subtract 6 minus 1, 2 minus negative 2. Those are the coordinates or the directed distance of the vector, AB. Now, we're also told that V is a vector, and he has these coordinates. That's given. And we're asked for the magnitude of the vector. Well, to find the magnitude of the vector, you square the first number, square the second number, add them up, and take the square root. So that's the square root of 10. The magnitude of the vector is the square root of 10. Remember, when you square, it's always positive. So please, I never want to see a negative number under here because you're squaring. All right, next we're doing V plus 2U. Well, let's see. U, that's given. That's the vector 1, 4. That's given. So we're going to take vector V, which is negative 3, 1, and we're going to add it to 2 U's. So 2 U's would be 2, 8. Remember, when you have a scalar out in front of the vector, just like with the matrix, you take that scalar times everything inside the vector. Now we're going to add them. So we add the x's and get negative 1, and we add the y's and get 9. And there is the final answer to the problem. Now we're also given a point C. Notice these are points. Those are vectors. And we're asked to find the opposite of vector BC. So I would start, if I were you, I would find BC, the vector from B to C. So from 6 to 5 is negative 1. And from 2 to 4 is 2. So there are the coordinates of the vector from B to C. Remember, starting, stopping. All right, now we need the opposite of that. So the opposite of this would be positive 1, negative 2. And there's the answer to that question. All right, now we need to find the magnitude of 2V plus 3U. So remember, this means magnitude, but we're going to find this inside part first. So we're going to hang on to that magnitude, and we're going to do this part first. So 2V, there's V. So 2V would be negative 6, 2. We just take 2 times everything in V. And then 3U's would be 312. 3 times everything in U. And now we're going to add them because the problem says add them. So we're going to add the x's and we get negative 3. And we add the y's and get 14. Now this is all of this. We did 2V plus 3U We added it together and got this. Now we need to do magnitude. Remember, when you do magnitude, you square the first one. You square the second one. Oh, goodness, 14 squared, 196. And we add them together. So when we add them together, let's see, what do I get? 205. Now, I don't know, does 205 break down? We always want to simplify if we can. So 205 divided by 5. Nope, doesn't look like it breaks down. So that is the answer to the problem. And then there's one more in that set there. It says find the unit vector in the same direction as AC. All right, so the first thing I have to do is find AC, the vector from A to C. So here's A, here's C. The vector from A to C would be 4, 6. So again, we're going from 1 to 5. That's 4 steps. And from -2 to 4, that's 6 steps. That's the vector from A to C. Now, to make it a unit vector, remember, you're going to have to divide each of these numbers by the magnitude of the vector. So let's find the magnitude of the vector. So we square the first one, square the second one, add them together and take the square root. So 16 plus 36. Now, I do believe that breaks down. 52 is a 2 and 26, which is 2 and 13. So this is 2 root 13. So we're going to divide each of these coordinates in the original vector AC by 2 root 13. And then we're going to reduce. 2 goes into 4 twice. So that leaves us with 2 over root 13. And 2 goes into 6 3 times. So that leaves us with 3 over root 13. And that is the answer to the question. Remember, to find a unit vector, you take the coordinates of the original and divide by the magnitude of that vector. This one we could simplify, so we did. All right, so now we're done with all that stuff. And now we are going to find a direction vector, or excuse me, direction angle for this vector. Now, I want to remind you that if you drew this vector, you'd come over 3 and down 2, so it would look like this. This is the angle that you want. This is going to be your direction angle. But you're not going to be able to find that right off the bat. The first thing you're going to do is make your little butterfly bow tie triangle, and you're going to find this angle right here, the one at the origin inside the triangle. Remembering that this is 3 and this is 2, I think you can find that angle. The tangent equals 2 over 3. The tangent of that angle equals opposite over adjacent. So then to find the angle, I'm going to go to my calculator and I'm going to do second tangent. Remember, when the variable is attached to a tangent or a logarithm or a sine, you always have to second. So second tangent in this case. So second tangent, 2 divided by 3. So this angle right here, theta, is 33.69. Now, that is not the answer to the problem, though, because remember, the purple is the answer to the problem. So if we went all the way around the whole thing, it would be 360. But we stopped with 33.69 to go. That's 33.69. So we went the whole way except for 33.69. So we'll subtract from 360. And the answer to the problem is 326.31 degrees. And that is the direction angle for this vector. Okay. Now we have a vector, and we got the picture drawn. Looks like this magnitude is 16 and this angle is 32 degrees. And we want to find the components. Now remember, components, coordinates, directed distance, all the same thing. It means these, x, y. That's what you're looking for. So we'll do what we did a minute ago. We'll make our butterfly bow tie. This is your x and this is your y. Obviously, this is the x-axis. This is the y-axis. And now we'll do our SOHCAHTOA. Cosine 32 equals adjacent over hypotenuse. Remember, x is always adjacent. Y is always opposite. So sine 32 equals y over 16. Now we'll multiply the 16 over in both equations, and then we'll just go to our calculator. So 16 cosine 32, 13.57, and 16 sine 32, 8.48. Now, one thing you definitely have to pay attention to here, though, this is the tricky part. See where we're located? Whatever x is, it's got to be negative because you're located in the second quadrant, so you're left and up. Y is still positive, but your x you have to make negative because you are in quadrant 2. All right, let's look at the next one. And again, this is going to be redundant. It's extra practice. If you don't want to do all this extra practice, fast forward through it. But we've got kind of the same thing now. So we're given some stuff. The first thing we want to find is vector AB, the vector from A to B, from 1 to -3, and from 2 to 4. So there are the coordinates of the vector from A to B. If you're going from 1 to -3, you're backing up 4. And if you're going from 2 to 4, you're going up 2. One more time, -3 minus 1, 4 minus 2. That's another way to calculate that directed distance. Now 2 is a little bit different. It says our BC, vector BC. Well, let's figure out what BC is first of all. C is 1, 5. All right, so let's find the coordinates of vector BC. From B to C would be +4 and +1. Those are the coordinates of vector BC, from -3 to 1 and from 4 to 5. Now, vector V is -2, 3. And the question is BC equal to V? Are those equal? Heck no. So the answer is no. And why not? They don't have the same coordinates. If you're going to be equal, you have to have the same coordinates. BC and V are not equal because they do not have the same coordinates. W is given, and now we're going to add V plus 2W. V plus 2W. So V plus 2W's, which would be 0H. Remember, when you have a 2 out in front, you double, well, any number out in front, you multiply that number times everything in the vector. Now, when we add them, we add the x's, so that'll be -2, and we add the y's, that'll be 11. So your vector is -2, 11. And that's the answer to the question right there. That's it. This means magnitude. So we're going to look at vector V, and we're going to square the first number. We're going to square the second number. We're going to add them together and take the square root. So the magnitude is the square root of 13. Please do not make that hard. You square the first number, square the second number, add them together, and take the square root. Now, number 5 is actually simple because we have everything we need. Remember, to find a unit vector, you take your original vector, which is -2, 3. That's our original V. And you divide each coordinate by the magnitude of the vector, which we already figured out was root 13. So our answer, there's no simplifying necessary. So this is our answer. We're done. That's it. To find a unit vector, you simply divide each coordinate of the original by the magnitude. Okay. Now we've got this scenario, and we want to know the components or the coordinates for the vector shown. Okay, so obviously that means we have to find x and y. So we'll drop a perpendicular here, and here's your x and here's your y. Components mean x comma y. And we're just going to do our SOHCAHTOA right triangle trigonometry. So cosine 42, cosine angle, equals adjacent over hypotenuse. And sine angle equals opposite over hypotenuse. Cosine is always x, sine is always y. And then we'll multiply and type it into our calculator. Now, in the last problem we did, we had to worry about negatives. Are we going to have to worry about negatives in this problem? No, you're right. We're in quadrant 1. This vector is in quadrant 1. And if you are in quadrant 1, then you are positive. So there are the coordinates of that vector, the x and the y. Okay, now we're going to find the magnitude and direction of an angle. So it's kind of backwards of that. We're going to take the angle, or not the angle, the vector, -2, -5. So it looks like this. And we're going to find the magnitude and the direction. So magnitude is easy. Pythagorean theorem, right here, Pythagorean theorem. We square the first one, 4. Square the second one, 25. So the magnitude of the vector is root 29. You square the first one, square the second one, add them together, and take the square root. So that part's easy. That's the magnitude. Now, the direction angle is this. The direction angle is that red. Remember, we always start measuring on the positive x-axis. Okay. Well, I'm not sure. What are we going to do here? We can't find the red thing to start with. So let's focus our attention right here on the purple. I'm going to erase that red and get it out of there for a second. Let's focus on the purple. Isn't it true that the tangent of that angle is 5 over 2? This is the opposite side. This is the adjacent side. So the tangent is 5 over 2. So we could find that angle by second tangenting 5 over 2. And I got 68.20 basically. So the purple angle is 68.20. But I don't want the purple one. I want the red one. And if I'm going to get the red one, how am I going to figure that? Well, remember, from here to here is 180. And then you're going 68.20 more. So if we just add 180, we're going to get our direction angle, which is 248.20 degrees. It's 180 plus the one in the triangle. Then it says sketch the vector representation of the course. Of an airplane on a bearing of 220 degrees. Okay, so here's our compass. This is 0. This is 90, 180, 270. And we're on a course of 220, which would be right here. This is 220. At a magnitude of 190 miles per hour. So there it is. That's all you have to do. You're just sketching it. That's it. Remember, anytime you're dealing with navigation, you are going to use these labels, the compass labels. Okay? All right, so now the next one has a lot of the same stuff, but this is good practice for us. So the first problem says find the coordinates of PQ. Well, we've done this several times already. So the coordinates of PQ from P to Q would be 2, 5. From -1 to 1 and from 2 to 7. 1 minus -1, 7 minus 2. Those are the coordinates of vector PQ. Now, they tell me that V is 2, -1, and U is 3, 6. And I am to find 3V dot U. Okay, we haven't done this yet today. 3V dot U. All right, well, first of all, 3V. 3V is going to be 6, -3. And we're going to dot that with 3, 6, U. So here's 3V, 3 times V, and U. Now, remember when you do a dot product, you take your X times your X, your Y times your Y, and you add them. So X times X, Y times Y, add them. This dot product is 0. Now, we learned in our one of our videos that when the dot product is 0, that means that your vectors are orthogonal. So that doesn't have anything to do with this question, but just as a little bit of a reminder, when the dot product equals 0, that means your vectors are orthogonal. Now we're finding the magnitude of v. Remember, that notation means magnitude. We want the magnitude of v. Well, the magnitude of v, we just square the first one, square the second one, add them together, and take the square root. So the magnitude of v is the square root of 5. Okay, now I'm going to leave PQ here because it's part of question 4. But I need R also. So point R is 0, 3. And I need to find QR, vector QR. And now on problem number 4, I already have PQ left over from a different problem. Now I have to find QR. So from Q to R would be -1, -4. 0 minus 1, 3 minus 7. So question number 4 says, are these two vectors equal? And the answer is no, because they have different coordinates. In order to be equal, you have to have the same coordinates. These guys have totally different coordinates, so they are not equal. And then question 5 says, find a unit vector for v. Find a unit vector for v. Now remember, what that means is you're going to take the coordinates of v and you're going to divide, here's v, you're going to divide those coordinates by the magnitude of v, which you have already figured out was √5. There's the answer to the question. Guys, it does not get any easier than that. All right. Oh, this has another page. All right, so we're going to find the components of the vector shown. I'm now on problem 6. So again, we've got the scenario. It looks like this. This is 12, and this is 63, and we want the components. Now remember, the components are simply x comma y. That's what you're looking for. So you're going to drop your perpendicular. Here's x, here's y. X is always horizontal, y is always vertical. So we've done this a couple times already. We're going to do sines and cosines. So cosine 63 equals adjacent over hypotenuse. Cosine 63 equals adjacent over hypotenuse. And sine 63 equals opposite over hypotenuse. So then we'll multiply by our denominator, our 12. And that is going to give us our coordinates. 5.45 and 10.69. Now these are the ones that you do have to pay attention to, positives and negatives. So you will want to look very carefully at your picture, but I think we're good this time because we're in quadrant 1. And in quadrant 1, everything is positive. So we're good. Perfect. Perfect, perfect. All right, now we're going to find, we have a vector whose coordinates are 4, -2. And we're going to find the magnitude and the direction angle. magnitude is easy. We've done a ton of these already today. We square the first one, square the second one, add them together and take the square root. This one works out to be root 20. Root 20 does reduce, so 2 root 5 is your magnitude. Square the first one, square the second one, add them up and take the square root. Now the direction angle is a little bit more complicated, but not bad. Let's draw a picture of this. So over 4, down 2. So here's a picture of my vector. This is the direction angle. But I can't find that. Instead, I'm going to find that angle. I always try to find the one inside the triangle at the origin. Now I know this is 4, and I know this is 2. So I know that the tangent of that blue angle is 2/4, or 1/2. So to find the blue angle, I'll do second tangent 2/4 or 1/2. I don't care if you do, it doesn't matter. 2/4, 1/2, it's up to you. But you have to second tangent to get the blue angle. Anytime you're finding an angle, you're going to have to second. So, second tangent 1/2, 26.57. So the blue angle is 26.57. Now don't put that down as the answer. The answer is the red angle. How are we going to figure out the red angle? Well, if we go all the way around the circle, it's 360. We didn't quite make it all the way around. We still had 26 to go. So we're going to do 360 minus 26.57, and your direction angle is 333.43 degrees. 360 minus 26.57. And then we got another sketch. So again, it's a directional thing. So we're going to use a compass. Here's our compass setup. Always, always, always. That's a 90. And we want 190 degrees. So 190 degrees is going to be right here. There's 190 degrees just past 180. And the speed is 200 miles an hour. Done. Okay, we have one more to go. And again, this is going to be some of the same stuff. But this is really good practice for us. Here's all the stuff they gave us to get started. And the first question says A, B, the coordinates of A, B. Oh my golly, we got to get this right. Negative 3 to 6 is 9. 5 to 4 is negative 1. So again, 6 minus negative 3, 4 minus 5. That's the, or those are the coordinates of the vector from A to B. V dot U. Now we're doing a dot product. So we're taking vector V and dotting it with vector U. Remember, when you do a dot product, you take x times x, y times y, and add them up. So negative 4 plus 6, the dot product is 2. The dot product of two vectors is always just a number, just a number, so it's 2 in this case. Now, this is a big problem. There's a lot to do here, but it's easy. Remember that the absolute value, the magnitude, kind of functions like parentheses. So you got to do what's inside the parentheses first. So we're going to take 2 times v, which would be 2, 4. And we're going to add u to that. So when we add the x's, add the y's. So here's 2v, there's u, and I'm adding x plus x, y plus y. Now I'm going to find the magnitude of that, and to find the magnitude, I square the first one, square the second one, add them up, and take the square root. So the answer to the question, the final answer, is the square root of 53. So we do what's inside first. So 2 times v, add it to u, and then do the magnitude. Okay. Ooh, now we haven't done any of these yet in this packet. Here are 2 vectors. And we are going to find the angle between them. Okay, so here's what we're going to do. We're going to remember our formula. The cosine of the angle equals the dot product, and I'll use C and D because that's the letters that I have, divided by the magnitudes times each other. That's our little formula to find the angle between 2 vectors. The cosine equals the dot product over the magnitudes. So we need to do the dot product. So remember, we just did one of these. When we do a dot product, we take x times x, y times y, and add them up. So 3 plus 12, that's 15. Okay? Now, we need the magnitudes. So to find the magnitudes, I'll do C first. We square the first one, square the second one, add them up and take the square root. So that's the square root of 45. Now, if you want to reduce that, you can. I don't want to confuse you at all, but this is not the answer. That is not going in the answer blank. It's easier actually to type in our calculator if we just leave it alone. Now, D, I need the magnitude of D. So I square the first one, square the second one, so that's root 5. Now, if you remember when we did these in the notes, I suggested that you go ahead and multiply these 2 together so that you have 1 radical instead of 2. So 45 times 5 is 225. Some of you might recognize that as a perfect square, and that's awesome. But don't worry about it because you're going to type it in on your calculator anyway. You have to find the angle. Our objective is to find the angle. So to find the angle, remember we have to second cosine that thing. And so when I second cosine that, because the formula is cosine theta, so to get theta we have to second. So second cosine 15 divided by the square root of 225, I got 0. The angle between these 2 vectors is 0, which means what would happen if we drew these 2 vectors? If the angle between them is 0, aren't they right on top of each other? Sure they are. And that happens, no big deal. So what do we need to know? We absolutely need to know that to find the angle between two vectors, we take their dot product, divide it by the two magnitudes, and that gives me the cosine, so I have to second cosine that fraction, and that will be my answer. All right, that's a good review problem. Okay, now I have a vector 2, -3, and I am once again going to find the magnitude and the direction angle. Magnitude is easy. I keep saying that. We keep doing it. Square the first one, square the second one, add them up, and take the square root. So magnitude is done. The magnitude is the square root of 4 plus 9. Remember, there's never any negatives under here. Now, to get the direction angle, I'm going to plot what I've got here, the vector that I've got. Looks like this. So if I make my little right triangle, I'm over 2, down 3. It looks like that. And the direction angle will be this. But of course, I can't find that right away. I'm going to find this first, the blue angle, inside the triangle at the origin. Now, what do I know about my blue angle? Look at it. I know the opposite is 3 and the adjacent is 2, so I know that the tangent is 3/2. That means the angle itself is second tangent 3/2. So second tangent 3/2, 56.31. So that angle is 56.31 degrees. So if you just look at your picture and use your common sense, the red angle is all the way around the whole circle except for the 56.31. So if we take 360 minus 56.31, we'll get our direction angle, which is 303.69 degrees. All right, I know this is a lot of practice work. 2 more, and then we'll be done. Remember, your direction angle is always measured from the positive x-axis. Okay, find a unit vector in the same direction as -3,1. So we have the vector -3,1, and we want to find a unit vector. Well, remember that your unit vector is always found by taking the coordinates of the original and dividing them by the magnitude. So we're going to have -3 over the magnitude and 1 over the magnitude. So we need to figure out what the magnitude is. Here we go, one more time. Square the first one, square the second one. Add them up and take the square root. There, my friends, is your unit vector. That's all there is to it. That is the vector that is in the same direction as the original, but it's only 1 unit long instead of √10 units long. To find a unit vector, you simply take the coordinates of the original and divide by the magnitude. All right, and finally we got a picture that looks like this. This thing's 19 units long, that's 27 degrees. And we want to find the components. And I even set up the parentheses for you there to remind you that that means find x and y. Components, x and y. So we'll make our handy dandy right triangle. This is x and this is y. X is horizontal, y is vertical. We'll use SOHCAHTOA. So cosine angle equals adjacent over hypotenuse. X is always adjacent. Cosine goes with X, always. And sine 27 equals Y over 19, opposite over hypotenuse. So 19 cosine 27 is X, and 19 sine 27 is Y. 16.93 for the X and 8.63 for the Y. Now this one is a little tricky because there is something you have to pay attention to. Do you see what it is? Yeah, your vector is in quadrant 4, which means your Y has to be negative. Your calculator isn't going to tell you that. You're going to have to pay attention to where you drew it. You drew it in quadrant 4, so X is positive, but Y is negative. And there's the answer to the question. And that takes care of those. Good work.